Let's read today Gottlob Frege. Frege, a German mathematician, logician, and philosopher, revolutionized logic by developing the first predicate calculus at the University of Jena. His formal system analyzed quantified statements and formalized proofs, influencing modern logic. Frege aimed to derive mathematics from logic, but an added axiom proved inconsistent. Despite this, his definitions and methods advanced number theory. Frege's comprehensive philosophy of language, influenced by the Stoics, remains insightful. However, his lifelong goal to reduce mathematics to logic ultimately failed. Frege, born on November 8, 1848, was a prominent German mathematician and logician. He studied at the University of Jena and the University of Göttingen, earning his PhD in 1873. Frege's academic career included significant contributions to mathematics, logics, and the philosophy of language. He published major works including Begriffsschrift and Die Grundlagen der Arithmetik, introducing concepts such as predicate calculus and the context principle. Despite his groundbreaking work, Frege's later years were marred by personal challenges and controversial political views. He died in 1925 in Bad Kleinen. He revolutionized modern logic by creating a system to formally study inferences, analyze complex sentences, and quantify phrases, and provide a unified theory of inferences. His contributions include an analysis of proof and definition, a flawed yet intriguing theory of extensions, and an analysis of numerical statements. He defined and proved basic axioms of number theory from primitive logical concepts and axioms. Frege's conception of logic as a discipline had compelling features. He aimed to realize Leibniz's vision of a universal formal language and rational calculus by developing a formal notation for thought and reasoning outlined in his Begriffsschrift and expanded in Grundgesetz der Arithmetik. Frege's system is a term logic where complete expressions denote terms. This system includes the analysis of ordinary predication and predicate calculus. In Frege's logic, sentences denote truth values, and functions map arguments to these truth values. Predication is analyzed as functional application, contrasting with modern predicate calculus, where predication is more fundamental. Frege's work laid the foundation for modern logic and influenced subsequent developments. He expanded his analysis of atomic statements to include complex and general statements using four functional expressions: statement, negation, conditional, and generality. Though his notation is no longer in use, it had all the expressive power of modern predicate calculus. Truth functional connectives, not if, then, and, or if and only if, were expressed through negations and conditionals. Quantified statements like every and some were also represented with universal and existential quantifiers. Frege's logic allowed a unified rule for inferences involving subjects and predicates, treating both as arguments of functions. His work laid the groundwork for modern predicate calculus and influenced the treatment of quantified expressions. His system consisted of a language and proof apparatus, including logical axioms and inference rules. Each proof step was justified by an axiom, rule, or previously proven theorem, defining a proof as a finite sequence of statements derived from axioms or valid rules. Frege emphasized clear definitions of logical and mathematical concepts, insisting that definitions be eliminable and conservative. He criticized piecemeal and creative definitions, which led to inconsistencies, and stressed that entities must be proven to exist before naming them, ensuring definitions did not introduce unjustified elements. His ontology comprised functions and objects, including truth values, the true and the false. In his 1893 1903 work, he associated each function with an object called the course of values, representing the function's value for each argument. Basic law 5 stated that the course of value of two functions are identical if they agree on every argument's value. Frege's term extension referred to this concept. However, Basic Law 5 led to Russell's paradox, undermining Frege's logicism, which aimed to derive mathematical principles from logic. Despite this, Frege's work significantly influenced later philosophers and logicians like Russell and Whitehead. In the Grundlagen der Arithmetik, Frege aimed to derive arithmetic principles from logical principles. He argued that numerical statements like "there are 8 planets" are second-level claims about concepts. A number statement makes sense only when a concept such as planet is specified. Frege defined numerical concepts logically. For example, two authors of Principia Mathematica means there are distinct individuals who satisfy the concept. He introduced the notion of equinumerosity, defining the number of a concept as the extension of all equinumerous concepts. Frege's insights laid a foundation for understanding numbers as logical entities. To define natural numbers, he introduced the concept of an ancestor in a relation series, particularly in the context of numbers. He defined the relation x precedes y and its ancestral relation x is an ancestor of y in the predecessor series. For example, 1 precedes 2 and so forth. Frege defined 0 as the number of non-self-identical concepts and natural numbers as either 0 or those where 0 is an ancestor in the predecessor series. Despite inconsistencies in his system, Frege validly derived the Dirichlet-Peano axioms from Hume's principle, forming the basis of modern number theory. His conception of logic. Before Russell pointed out the inconsistency in his system, Frege believed he had shown that arithmetic could be reduced to logic. Today it is recognized that he showed arithmetic reducible to second-order logic extended by Hume's principle. Philosophers debate whether Hume's principle is analytically true. Frege thought arithmetic derived from analytic truths, whereas Kant saw arithmetic principles as synthetic. Frege's logic included more resources than Kant's, avoiding appeals to intuition. Despite challenges, Frege's work laid a foundation for understanding the relationship between logic and arithmetic, influencing later developments in the field. He developed a philosophy of language while investigating mathematics and logic, which has significantly impacted both fields. Bob Zine suggests that Frege adapted key elements from Stoic logic. A central aspect of Frege's philosophy is the distinction between sense and denotation. To illustrate this, we explore two key puzzles Frege aimed to solve and how the sense denotation distinction addresses them. Lastly, we contextualize Frege's philosophy of language, considering recent research highlighting the influence of Stoic text on his ideas. Frege's puzzles. Frege's seminal paper on sense and reference addresses two key puzzles in language: identity statements and propositional attitude reports. Frege observed that understanding sentences cannot rely solely on denotations of terms. Identity statements like Mark Twain is Samuel Clemens differ in cognitive significance from Mark Twain is Mark Twain, despite denoting the same object. Propositional attitude reports, such as John believes that Mark Twain wrote Huckleberry Finn, can change the truth value when substituting synonymous names. To resolve these issues, Frege introduced the distinction between sense, the mode of presentation, and denotation, the referent, profoundly influencing linguistic philosophy. Frege's theory of sense and denotation. Frege suggested that names and descriptions have both a sense and a denotation to solve puzzles about identity statements and propositional attitude reports. The sense accounts for the cognitive significance of terms, while denotation refers to the actual object. For example, 4 and 8 by 2 have the same denotation but different senses. In propositional attitude context, terms denote their ordinary senses rather than their usual denotations. This explains why substituting synonymous names in sentences like John believes that Mark Twain wrote Huckleberry Finn does not preserve truth. Frege's distinction between sense and denotation addresses these semantic challenges, influencing linguistic philosophy profoundly. Frege's philosophy of language in context. Bobzin argues that Frege adopted Stoic ideas from Karl Brandt's History of Western Logic and Diogenes Laertius' Lives of the Philosophers. These works detail Stoic view on language and logic from philosophers like Zeno, Cleanthes, Chrysippus. Bobzin shows that Frege's training enabled him to understand the quoted passages in Greek and Latin. She provides extensive comparisons of Stoic and Phrygian texts, revealing striking similarities, particularly in their treatment of semantic content and propositional connectives. While Frege brought original insight to formalizing logic, many of his underlying approaches to language are traced back to Stoic philosophy. That's all. Thank you.